what we already have had a look at is just the basics of analytical, so gradient, distance, midpoint, angle of inclination. And then we started looking at our circle knowledge that some of you might have done in grade 11, some of you only maybe do it in grade 12. It depends on your teacher and your school. But we've had a look at circles, how we identify center, how we identify the radius, how we find the equations of circles, and we've had a look at tangents to circles. And so what we're going to have a look at today is points and lines that have to do with circles. Because what you're going to find is, as you go through past papers, there were often questions, and generally we classify them as complex questions. They're generally questions around, does a specific point lie in a circle? Or do these two circles touch each other? Does the line with a specific equation intersect the circle as a tangent, as a secant, etc., etc.? And we're going to have a look at how to deduce whether or not those things actually happen in this lesson. Alrighty, so just remember, take screenshots, especially for the first little bit and like the middle bit, because there's a bit of information, a summary, I suppose, of how you can go and determine whether or not a point is lying within, on, or outside a circle, and whether or not a line is a tangent, outside, or a secant to a circle. I will explain what all of those things mean as we go along. Okay, so just remember, guys, that formula up there in orange is your circle formulae, or equation to your circle. And that essentially gives us information about our circle in terms of its radius, its center, in center radius form. Alrighty, so what I have here is just a summary of how we can find out whether or not a specific point lies in, on, or outside a circle. So as you can see here, to determine whether a point lies inside, on, or outside a circle, what we do is we compare the distance between the given point, the point I've told you, and the center of the circle. If we know how far away that point is from the center of our circle, we can determine whether or not it lies inside or outside. And the reason we can do that is because based on our formula, we know the radius of our circle. So if we know how far away the edge of our circle is because of our radius, and we know the distance from the center to whatever point I'm looking at, I can determine whether it's as long as the radius, so on the circle, shorter than the radius, so in the circle, or longer than the radius, so outside the circle. And that's exactly what this little summary down here says to you. So the first situation, so TC is the length from your center to your point. So I'm just using point T. So if the length from your center to your point is less than your radius, it's inside the circle. If your length from the center to your point is equal to your radius, it's on the circle circumference. And if the length of your let's try those words in another order. If the length from your center to the point is greater than your radius, it falls outside your circle. So that's essentially how you can now go and figure out whether or not a point is in, on, or outside your circle. So I'll give you a second to screenshot that, and then we'll have a look at some examples. Okay. So if we have a look at our first example here, I'm just going to make this a bit bigger for us. So the first example here says, does the point A26 lie inside, outside, or on the circle x minus 7 squared plus y plus 10 squared equals 49? Okay, so there's a couple things that we need to figure out. We know based on my little summary that I gave earlier that we need to figure out what our radius is, and we need to know what our center coordinate is, because we need to compare the distance from the center to the point as well as, or in comparison to the radius. So can anyone tell me what the radius of the circle is? What is the radius of the circle? And just give me the number. So remember the circle is x minus a squared plus y plus minus b squared is equal to r squared. That's the equation of your circle. So again, what is the radius of your circle? Nice, Awami. Exactly, guys. Our radius is 7 units. All you do is you take that value that is the r squared, or that represents r squared, and you square root it. Okay, cool. Can anyone tell me what our center coordinate is? Where would we find the center of the circle? Nice, Tanda. Very nicely done. You guys remember your center coordinates is always the opposite sign. So it's positive 7 and negative 10. So 7, negative 10. Oh, negative went a bit weird there. Okay. So I've got those two bits of information. So what I want to do is I've got point A. I want to work out the length or the distance from A to C. So I'm going to use my distance formula. Now, your distance formula, remember, is on your formula sheet, but it's x2 minus x1, or you can go the other way around. It really doesn't matter. Squared plus y2 minus y1. So the two coordinates that I'm working with, because let's make sure we're working with the correct information, is A and your center. Oh, that's not letting me highlight it. There we go. Okay. So if this is point 2 and this is point 1, x2 is 2 minus 7 squared plus y2 negative 10 minus 6 squared. If you did it the other way around, that's absolutely fine. It makes absolutely no difference. Just make sure, obviously, you get your signs correct, but it really doesn't matter. Alrighty. Also, it would help if I put in the right order. Hey, I just hopped on about order. So this would be 6 plus 10. I do apologize. Right, you just put that into your calculator. You don't need to do anything more. I don't need to see your working out. This gives us 16,76 units. Now, remember, what we want to compare now is the length of our radius to the distance between center and the point we are in question, we are looking at. So here what we can see is that the distance of AC is much greater than our radius, or you could write it that the length of AC is much greater than our radius. And we know that when the length from our center to our point is much longer than what our radius is, our point A, or the point we're talking about, falls outside our circle. And the question did ask, does it fall inside, outside, or on? So we do actually need to make that statement. It is falling outside our circle because it sits much further away from the center than the edge of our circle, i.e. the circumference. Right, so we make comparisons between length from center to point and radius of the circle. Okay, I'll make that a bit smaller for you to screenshot in a second. Let's have a look at this second example here. So this second example is pretty much the same, except our circle equation is in its standard form. It's not in center radius form. So it says determine whether the point 4,1 lies inside, on, or outside the circle x squared minus 8x plus y squared plus 6y minus 2 equals 0. Now remember, we said earlier, the two bits of information we need to know are the radius and the center. So who can tell me what I need to do in order to get the, oh, no, I don't know why I've questioned my words there. Who can tell me what I need to do in order to get the center and the radius? How do I get that information based on this equation that I've been given? Lumiso, very, very nice. We need to go and complete the square. Okay, now again, if you aren't a fan of completing the square, we did do a whole lesson on it. So go and have a look. I'm going to just talk you through it, but I'm going to do it relatively quickly. What we do is we group our like terms. Now, when I say like terms, I don't mean it in the traditional sense of like terms. I mean, put your x terms together and put your y terms together. So that's going to be x squared minus 8x, x squared Let's try that again. Plus y squared minus 6y, plus 6y, sorry. And then we take the constant over, so it becomes equals to 2. Once we've done that, we can now complete our squares. So we know that we're going to have x minus half of that coefficient, so 4 squared, plus y plus half of that coefficient, so 3 squared, is equal to. Now remember, what you are doing is you're adding a 4 squared and a 3 squared on the right-hand side. So on the left-hand side, sure. So on the right-hand side, I've got 2, but I need to remember to add a negative 4 squared and a 3 squared. Because I've added that on the left, I must add it on the right. So my circle's equation in the center radius form is x minus 4 squared plus y plus 3 squared is equal to 2 plus 16, which is 18, plus 9, which is 27. So now I know what my radius and my center is. So radius, remember, is the square root of the right-hand side, so of r squared. So that would be square root 27. I will fix that now. You can write it as a decimal if you want to. It's actually going to be quite helpful for you to know what it is. As a decimal, it's 5,20. Just makes it easier to compare. And we know that the center of our circle is at positive 4, negative 3. So we have those 2 bits of information. I know what my radius is, but I do need to go and work out the length from my center to my point. So I'm going to use my distance formula. Just grab our information. So the point in question is 4, 1, and I want to work out the distance from the center. So that would be 4 minus 4 squared plus 1 plus 3 squared. And that's all being square rooted. Chuck it into a calculator and you get an answer. So what this ends up being, obviously 4 minus 4 is 0. 1 plus 3 is 4. So 4 squared is 16, but the square root of 16 is 4. And so the distance from my center to my point is 4 units. The radius is 5.2 units, so it's a shorter distance. The distance is shorter than the radius. So because my radius extends to the edge of my circle and the distance to that point is not yet reaching that circumference, it means that the point 4, 1 lies inside the circle. Okay, so working out the distance from your center of your point is very, very useful to determine whether or not something falls within, on, or outside your circle. Okay, so let's do this so you can take a screenshot. So there are your first 2 examples. I'm going to do this properly now. It's just fine. There we go. All right, guys, don't forget, if you've got questions, please ask. You know this, so just make sure you are asking if you need. But essentially, know your distance from point to center and what your radius is, and you can then compare and see what that means in terms of where your point lies. Right, you're going to try one by yourselves now. So screenshots. And then I want you to have a look at this question over here. Let's make this a bit bigger again. Okay, so there's 2 questions. Determine whether the point negative 1, 1 lies on the circle x minus 3 squared plus y. Oh, there should be a squared there, so sorry. Y plus 1 squared equals 25. So sorry, there should be a squared there. Squared. Okay, cool. Squared. Doesn't want to be squared. There we go. And then determine where the point A, 3, negative 2 lies on the circle given by that equation. Okay, I'm going to give you 5 minutes. Let's give it a try and then we'll have a look at the answers. Please do ask me questions if you have any. Let me help you if you are feeling a bit stuck. And remember, guys, you're more than welcome to put your answers in the chat, that others might be helped by your answers. I can check your answers or ask me questions. You've got another 3 or so minutes. Okay, great tools. Can you just give me a thumbs up if you're done and a thumbs down if you need another minute or 2? Awesome. Thanks, guys. Okay, so let's have a look. Right, so here we have it. Pretty sure you can see everything. Yeah. For the first one, nice and easy, you could tell immediately what the center was, what the radius was, so you didn't have to do too much there. You just had to work out the distance between your point and center. Because that distance was less than your radius, it meant that the point was inside the circle. For the second one, you had to complete the square so that you could work out where your center was and what your radius was. And once you had done that, you could go and work out your distance. Now, what you saw was that the distance between center and the point A and your radius was actually the same length. And so what that means is that the point actually sits on the circumference. So it lies on the circle. Right, so that's why having that little summary right at the beginning is quite useful, because it allows you to then determine what's what. I'll just wait here in case you want to take a screenshot. But essentially, that's one way we can ask the question. So determine if the point is in, on, or outside. Another way we can ask this question is to tell you this point lies on the circle, or this point lies, I don't know, 3 units away from the circle, something like that. We can give you information and then ask you to work out something about the coordinate. So in this case, in example 3, it's exactly that. I've said determine the value of point P, and if you now have a look at this next bit of information, P is the y coordinate of A. So if point A, negative 3P, lies on the circle x minus 2 squared plus y minus 1 squared equals 50. So really importantly here, I am telling you it lies on the circle. So immediately we should be thinking, okay, cool. That means that the distance from center to point A, let's try this again. So A to center is equal to my radius. That is essentially what I'm trying to tell you here. And that's going to be important because we know in analytical geometry, if we are going to use the distance formula to work out an unknown coordinate, I need to know what the distance is. Okay, so using the equation of my circle, I know that my center is at 2, 1. That looks like a 7. Let's fix that. But more importantly, my radius is equal to the square root of 50. Now, you are more than welcome to go and write that as whatever the square root of 50 is. I don't particularly mind, but there's no need. Because what we now can do is, because we have that bit of information there that says the distance from A to my center is exactly the same as my radius, I can now go set up an equation. I know that to work out the distance from A to C, or A to my center, I would take -3 minus the x-coordinate of my center, which is 2, plus p minus 1 squared, and that must be equal to the square root of 50. That's information that I have. Now, there's 2 ways you can solve this equation. I'm going to show you both just because one is a little bit easier than the other. And it doesn't always work out like this. So when in doubt, do this first method. But the second one is also perfectly fine. Okay, so what the first method tells us to do is, because we've got a square root on both sides, if I square both the left-hand side and the right-hand side of this equation, what essentially is going to happen is it's going to get rid of the square roots. Wonderful. So what that now means is I've got this bracket of -3 minus 2 squared, which is -5 squared, so 25, plus the bracket p minus 1 squared is equal to 50. Please notice that by squaring both sides, you are not getting rid of the squares underneath the square root. Those are still there. All you have done is gotten rid of the square roots. That's it. The next thing that we do is we distribute this bracket. So remember, this bracket is a binomial times a binomial. So it's p minus 1 times p minus 1. So I just distribute that, giving me p squared minus 2p plus 1. And because of that p squared, I have a trinomial. So p squared minus 2p, 25 plus 1 is 26. But then when I bring that 50 over, it becomes minus 50, so minus 24. And now I factorize. So this is p minus 6, p plus 4. And so my 2 values of p is -6, or don't know why I say -6, +6, or -4. So I actually should have said in the question, determine the value or values of point P, but that doesn't matter. So I've got my 2 coordinates that P could potentially be, so that point A lies on the circle. Right, the other way that you can do this, and I'll be honest, I wouldn't even do it the second way, just in case I do a silly mistake. But the other way that you can do this is from the point where you have squared both sides. What you have is 25 plus p minus 1 squared equals 50. If you take that 25 over, you've got the brackets p minus 1 squared is equal to 50 minus 25 is 25. And what you can do is you can now go and square root both sides. Now, what you need to remember is that when you square root both sides, it is a positive or a negative value that you are getting. And so what that means is that p minus 1 is equal to positive or negative 5. So if we take the scenario of positive 5, whoops, sorry, didn't need to do that. So p minus 1 equals positive 5, or p minus 1 equals negative 5. Those are the 2 possible solutions I have once I've square rooted. That then means that p is equal to 6, so the same answer, or p is equal to -4, same answer. So I don't really care how you choose to do it. However, if you're going to do the second method, you have to remember that plus or minus. If you don't remember that plus or minus, you are ignoring an entire solution and you're going to lose marks. So I would definitely recommend rather just distributing and then factorizing, but it is up to you. If you're comfortable and you know you're going to remember your plus or minus when you square root, that's absolutely fine. Okay, so sometimes we do tell you the point lies on the circle, or give you information about where the point lies, and you have to go and work out from there. Okay, so let's take a screenshot, and then let's have a look at our next example. Okay. So, exciting. So the next thing that we need to be mindful of is whether or not lines intersect with a circle. Just make sure you can see everything here. You can. Great. So whether or not lines intersect with a circle. Now, we should remember from geometry these different terminologies here, but just in case, let's have a look. So we are able to use simultaneous equations to determine points of intersection between circles and lines. To do this, you have to use simultaneous equations because that's essentially what a point of intersection is. We spoke about this when we did do simultaneous equations when you were in grade 11. We've spoken about it in functions. That is essentially how you go and solve for a point of intersection. Now, there's three possible things that can happen when you're talking specifically about lines and their intersections with circles. The first thing that can happen is that you get 2 points of intersection. And this is what we call, this line specifically, is what we call a secant to the circle. So again, you should remember that from your Euclidean geometry from grade 10, 11. So a line that extends past the edge of the circumference but cuts a circle in 2 places is a secant. A chord, just so that you are aware of the difference, goes from one end of the circumference to the other. Okay, it doesn't go past the bounds of your circle. That green line is a chord. If it goes past the edge of your circle, it's a secant. Okay. The next thing that can happen is that there's only 1 point of intersection, and we know that that means that that line is a tangent. And we've done some work on tangents already. The third thing that can obviously happen is that there's no points of intersection. The line does not intersect with the circle anyway, no points of intersection, that's that. So yes, the third scenario is definitely good to know, but the first two are generally more what we are looking at. But I'm not saying that the third can't come up. Okay, so let's take a screenshot and then let's have a look at how we can now apply this knowledge to determining points of intersection between lines and circles. Alrighty. So just remember that if you are asked to prove that a line is a tangent, so remember, anytime you are asked to prove something, you actually need to show that the statement would be true. So what I mean by that is you would need to show that there is only 1 point of intersection between line and circle. So it's the same as if you were being asked to prove 2 lines are parallel to each other, you would have to actually show that, for example, the corresponding angles are equal, or the co-interior angles add up to 180 degrees. If you were proving a cyclic quad, you would actually need to show that angles in the same segment are equal. Exterior angles equal to the opposite interior, etc., etc. So if you are asked to prove that a line is a tangent to a circle, you need to go and show that the point of intersection, there is only 1. Right, but let's have a look at this example. Just want to make this a touch bigger. So example 4 says, the straight line y equals x plus 1 intersects with the circle x squared plus y squared equals 25. Determine the coordinates of the points of intersection. So I said point or points. We're not too sure which one, but we're going to go and work it out. Okay. So if we have a look there, we've got 2 equations. We've got the equation that again. Y equals x plus 1. And we have the equation x squared plus y squared is equal to 25. Now, automatically, this should immediately remind you of simultaneous equations. There's two equations. I've got one linear, one quadratic. And what you need to be mindful of is the fact that I've actually already given you an equation where y is isolated. So you can now take this immediately and you can substitute into your second equation and replace y with x plus 1. So that means x squared plus x plus 1 squared is equal to 25. And we now go and solve for x. So you need to distribute that bracket. Remember, it's x plus 1 times x plus 1. So that gives me x squared plus 2x plus 1 minus 25. Because remember, we want to make one side equal to 0. And now we collect our like terms. So 2x squared plus 2x, 1 minus 25 is minus 24, is equal to 0. And now we factorize. However, I do see that all of those can be divided by 2. So I'm actually going to simplify my life. I'm going to divide everything by 2, giving me x squared plus x minus 12. If you can divide by a common factor, it just makes your factorization so much easier. I'm not saying it's wrong to not do it. It just makes life easier. So this is now a very easy trinomial. I can go and factorize. X plus 4x minus 3 is equal to 0. And so x is equal to negative 4, or x is equal to 3. Now, grade 12 is really importantly, and we often do this with simultaneous equations as well. It says determine the coordinates of the point of intersection. That is meaning, I don't think that's very good English. Let's try that again. That means I want an x and I want a y. I want both. Right now, I have just worked out x's. You need to sub those both back in to find y. Now, I would obviously sub it back into the linear equation because subbing it back into the quadratic is just slightly harder. So if I substitute a negative 4 plus 1 is then minus 3, and 3 plus 1 is 4. So either my points of intersection are at negative 4, negative 3, and 3, 4. So what this actually means is that the line that I'm working with here is a secant to my circle. But you've got two different points of intersection. It means the line cuts my circle twice, beautiful circle like that. And you've got your 2 points of intersection. Negative 4, negative 3, 3, 4. Okay. So when you are looking for points of intersection, and guys, this is true for any situation where you want a point of intersection, you are doing simultaneous equations. You are equating the two equations, but all that actually means is you are looking for or working with a simultaneous equation. All right, so let's screenshot that and then let's have a look at another example. Remember, guys, if you've got questions, please ask, because this does rely on a lot of knowledge from geometry, functions, your grade 11 analytical geometry. So please just make sure you are asking if you're a little bit unsure. Alrighty. Okay, so we have been asked to determine the coordinates of the point of intersection between the circle x squared minus 2x plus y squared minus 4y minus 8 equals 0 and the line y minus x equals 2. Now the I don't know what happened there. The very first thing that I want you guys to remember is the fact that the second your straight line formula is not in standard form, you put it in standard form, okay? The reason you do that is because you are then immediately isolating y. Now, obviously, because this is a simultaneous equation, if you felt you wanted to isolate x, that is obviously absolutely fine, but I am going to isolate y. So my equation was y minus x equals 2. I'm going to get y by itself. So that means y is equal to x plus 2. Bring the x over, it becomes positive. My second equation, x squared minus 2x plus y squared minus 4y minus 8 is equal to 0. And so remember, what I now have is a y value that I can substitute in place of my y's. Okay, there's just a question here. So the question is, to do simultaneous equations, do both equations have to be in standard form? No. So it is up to you. Personally, I would not suggest completing the square here just because then you're adding an extra step. It's not wrong. So in this last example, okay, it's poor choice of words, but no, you don't have to complete the square, nor would you have to expand brackets of a completed square equation. The only one I would suggest putting in standard form is your straight line, because like I said, then what you're essentially doing is you're isolating your variable y for you to go and substitute into your other equation. But we also know you don't have to isolate y. So if you wanted to isolate x, that would be fine too. So no, they don't have to be in standard form. Not a must. Right, so we've got x squared minus 2x plus, now I'm going to substitute in my x plus 2 in place of y squared minus 4 times y, so whoops, x plus 2 minus 8 equals 0. And now you expand. So x squared minus 2x. Remember, this is a binomial, x plus 2 times x plus 2, so that would be x squared plus 4x plus 4. Distribute in minus 4x minus 8 equals 0. Simplify, so x squared plus x squared is 2x squared. Then we've got our x term, so minus 2x plus 4x minus 4x is just minus 2x. And then we've got plus 4 minus 8, that gives us negative 12. Now again, I can see that I can divide everything by 0, so I'm going to do that by 0. Oh my gosh, by 2. So x squared minus x minus 6 equals 0. Much easier trinomial to factorize. X minus 3, x plus 2. And so what that means is I know my x coordinates are at 3 or negative 2. Now remember, that's just the x coordinate. You still need the y coordinate. So we sub back in. Again, I would sub back into my linear. 3 plus 2 is 5, so y equals 5. Minus 2 plus 2 is 0, so y equals 0. So my 2 points of intersection are at 3, 5 and negative 2, 0. You don't have to write out the coordinate like I've done. Leaving your answer like that in the block is absolutely fine. I'm just a little bit pedantic when it comes to, if it says determine the coordinate, I like to write down the coordinates, but you don't have to. Alrighty, so let's take a screenshot and then you're going to try one by yourselves. Okay, so again, remember, your equations do not have to be in standard form. I would suggest putting the straight line one in standard form if it isn't, but it's not a must. As long as you understand that to do a simultaneous equation, you have to isolate a variable, substitute it into your other equation and solve, you're good. Alrighty, so let's try these examples rather over here. I'm going to give you 5 minutes, should be enough time, and then we'll have a look. Just want to turn my lights on. Okay, and guys, remember, if you've got questions, please just ask. But like I say, I'm going to give you another 4 or so minutes and then we'll have a look. Okay, guys, when you're done, can you just give me a thumbs up? If you need another minute, just give me a thumbs down. Okay, I'm not getting anything else, so I'm going to assume that we're good to go. Let's have a look. Let's make it a touch smaller. Okay, so that was your example. You had to find the coordinates of the point of intersection. So what you should have found in the first one is that you ended up only getting one point of intersection because, as you can see, the brackets ended up being the same. So you had 2 brackets of x plus 2, x plus 2, which means you've only got one x value of 2. That means you can only get one y value. And so there's only one point of intersection, which means you're working with a tangent. For the second one, straightforward 2 points of intersection, it's a secant. Owami?
Ma'am, for the first example, wouldn't x be a -2?
Let's just double check my math because we know that
Or
this happened.
in the when you factorized, the brackets
So
were
over there. Okay, so let's just make sure. So we've got our y value.
Ma'am, I'm saying the bracket here is correct, but the answer underneath it would be -2.
Right, sorry. Yeah. And just see what. Yes. Right, let me fix all of that nonsense. Okay, so yes, this should be -2, which means that when we substitute back in, we get +2. So do we agree with that? So -2 + 2. Is that better? I'm going to assume yes. Sorry, guys. I got excited about the 2's clearly. So yes, -2, +2. I appreciate you being on it. Thank you, Awami. But there we go. Right, so let's take a screenshot. And I want to do this last example just so you can see how we would go about answering a question that asks us to prove that a line is a tangent. Okay. Right, so this last question here says, show that y minus 3x equals 5 is a tangent to the circle x squared minus 2x plus y squared plus 4y minus 5 equals 0. Lots of words there. Okay, so remember, I said earlier, for you to show that a line is a tangent, you need to show that there is only one point of intersection. Oh my gosh, only one point of intersection. So like what you had in question A over here. I'm sorry if you can hear that, it's very annoying. So like what we had in the situation over here. We have to go and essentially solve simultaneously to show that we've got one point of intersection. So again, isolate your y. Y is equal to 3x plus 5. And we're going to substitute that in place of our y's. X squared minus 2x plus y squared, so 3x plus 5 squared, plus 4 times y minus 5 equals 0. So we're doing exactly the same thing to show that there is only one point of intersection. So this results in us having x squared minus 2x. Remember, binomial, so plus 9x squared plus 30x squared, 30x rather, plus 25. Distribute in your form, plus 12x plus 20 minus 5. And now we collect our like terms. Okay, so x squared plus 9x squared is 10x squared. Minus 2x plus 30x is 28x. Sorry, it's 28x plus 12x is 40x. And then our constants, 25 plus 20 is 45, minus 5 is 40. Now again, I can divide everything by 10, so I'm going to do that. And then, shockingly, I'm going to have the same trinomial that I am now going to solve correctly. And so we get x equals -2. Right, we substitute back into our equation to solve for y. So that means y is equal to -2 times 3, so -6 plus 5, which is -1. We only have one point of intersection. So therefore, y minus 3x equals 5 is a tangent as there is only one point of intersection. So when proving something is a tangent, you want to prove that there is one and one only point of intersection because that makes it a tangent. All right, guys, so let's screenshot that. There was just a question for me to go back to the summary for the circle, so I'm just going to do that in a second, but take your screenshots. If you have them and you don't need me to go back, you're more than welcome to leave. And I will see you guys on Wednesday when we will wrap up our analytical. Good luck for your exams if you have started already, but I will see you guys on Wednesday.